A second example of complements. The objective of this example is to demonstrate how complements can be combined with intersections and unions. I'm going to give you 4 problems to try on your own first before revealing the answers. Number 1, the mathematical notation here means that you have set C with the union of set of the complement of B. Number 2, this notation means that you have set B and you're looking for the intersection for the complement of set C. Number 3, this notation means that given set C, find the intersection with the complement of set B. And number 4, first you find the union of sets B and C, and then find the complement of that union. As you work on these by yourself, here's a hint. Shade the diagram as you go to help you find the solutions along the way. This is a good opportunity for you to pause the video, and then when you find your solution to all 4 of these, resume watching the video to reveal what the answers are. Now that you've had an opportunity to write all 4 answers, let's go through and review each answer one at a time. So the answer for number 1, set C with the union of the complement of set B, is 1, 2, 3, 4, 5, 6, 7, and 11. All the numbers that are highlighted in yellow. But how did we get that answer? Well, let's take a look at the complement of set B. The complement of set B are all the numbers that are not in set B. So here we have 1 and 5 out here in the universe, 6 and 7 from set C, and then 11 that's also out here in the universe. Also, we want to look at the complement, or we want to look at set C, not the complement of set C, but set C itself. And set C are the numbers 2, 3, 4, 6, and 7, all the numbers within the circle of set C. Now the union would be the combination of those 2 sets. So I take everything in set B and everything in set C and join them together. If there are repeats, like we see here, but they both contain 6 and 7, we only need to write it once. For number 2, set B with the intersection of the complement of set C, we see the answer is 0, 8, 9, 10, and 12. Everything highlighted here in yellow. But how did we get that? Well, first of all, let's take a look at set B. Set B are all the numbers that are located within set B, including the intersection. So it would be 0, 2, 3, 4, 8, 9, 10, and 12. The complement of set C would be all the numbers that are not in set C. So that would be 0, 1, 5, 8, 9, 10, 11, and 12. Now next we would look for all of the numbers that are in the intersection, or numbers that they share. So we see that set B and the complement of set C both contain a 0. They also both contain the number 8. They also both contain the number 9. They also both contain the number 10. And they also both contain the number 12. So the numbers I highlighted here will show up here in the intersection of set B and the intersection of complement of set C. In the Venn diagram, it would be all the numbers that are highlighted in yellow. Okay, so let's take a look at number 2, set B with the intersection of the complement of set C. And we see here in tabular form, the answer is 0, 8, 9, 10, and 12. In the Venn diagram, it's everything here highlighted in yellow. So how did we get that for an answer? Well, first of all, let's take a look at set B. Set B are all the elements within the circle or within the diagram of set B. So they would be the numbers 0, 2, 3, 4, 8, 9, 10, and 12. For the complement of set C, they would be all the numbers that are not in set C. So basically write down every number except the numbers that are in set C. So we get 0, 1, 5, 8, 9, 10, 11, 12. Now for the intersection, we're going to indicate the numbers that are in both sets. So we see that 0 is in both sets. We also see that 8 is in both sets. So I'm going to highlight those. 9 is in both, as well as 10 and the number 12. So the highlighted numbers up here will show up down here in the answer for number 2. So the intersection of set B and the complement of set C are the numbers 0, 8, 9, 10, and 12. For number 3, We are looking for the intersection of set C and the complement of set B. And we can see the answer is 6 and 7, and in the diagram, it is everything that's highlighted in yellow. So how did we get that answer? Well, first I'm going to list the complement of set B. The complement of set B are all the numbers that are not in set B. So that would be 1, 5, and 11 out here in the universal set, and then 6 and 7. Even though 2, 3, and 4 are in set C, they're also part of set B, so I left them out. Now for set C, those are all the numbers within the circle set C. So that's 2, 3, 4, 6, and 7. And at this point, I'm going to look for numbers that they have in common. That would be the intersection. And the numbers they have in common are 6 and 7. So that's what I put down here for the answer for number 3. The intersection of set B, I'm sorry, I said that wrong. The intersection of set C with the complement of set B are the numbers 6 and 7. And now we're ready to look at number 4. Number 4 is the union of sets B and C, and then we find the complement of that. So the union of sets B and C are everything within set B and set C. But the complement would be the numbers that are not in that union. So what you see highlighted in yellow is the universal set. So here we have 1, 5, and 11 are the complement to the union of sets B and C.